Any object in space has certain measurable quantities that relate to its motion. These include position, velocity, and acceleration. The position of an object is the length of the line joining the reference point, often where the observer is, and the point where the object is in space. This is often represented as an arrow, which we call a vector. Generally speaking, a vector is a quantity with a specified magnitude and direction. If any one of these two attributes changes, the vector is said to have changed as well. A change in position of an object is called displacement, and it too is a vector quantity. Displacement is different from distance, in that displacement is the length of the vector joining an initial and a final position, irrespective of the path used to travel between them, whereas distance is the length of the path that you use to travel between those 2 points. Distance is classified as a scalar quantity because it has only a magnitude and has no particular direction. A classic example of the disparity between displacement and distance is illustrated in an object that moves through a closed path, meaning that it comes back to its original position. In this case, displacement is 0, while distance traveled is the length of the path. Velocity of an object relates to its motion. It is the rate at which the position of the object is changing with respect to time. This too is a vector, meaning it has a specified magnitude and direction. So, if an object is here at a point in time TA and moves to a new position B, at which it arrives when the time is now TB, then the velocity of the object in the direction AB can be easily calculated. This is an average velocity, since it is calculated from motion that has occurred over a substantial period of time. Average velocity overlooks the details of the motion of an object. For instance, if I travel between 2 cities that are 100 kilometers apart in 1 hour, my average speed is 100 kilometers per hour. This doesn't necessarily mean that I never stopped at intersections or traffic lights. So, whether I stopped for 10 minutes or even reversed at some point in my journey, that information is hidden if all there is an average velocity. So you can imagine average velocity as a kind of zoomed out motion where you can see an object drifting from one point to another, but you can't really observe the minute details of that motion, like change in direction, slowing down, or speeding up. To get more details about the motion of an object, we often rely on the instantaneous velocity of the object. This is done by observing the object's changes in position over very short time periods for the entire journey. As the time period shrinks to 0, this allows us to calculate the object's velocity at any given point in time, and we call this the instantaneous velocity. Instantaneous velocity gives details of the motion at any particular point in time. So, in our intercity journey, we can now note when the car is slowing down, speeding up, or stationary. This is similar to zooming in on the motion of an object, which allows you to see small details about its motion. Velocity is not to be confused with speed of an object. Speed does not consider any particular direction, meaning that it's classified as a scalar quantity. Average speed is calculated from the length of the path traveled between the 2 points, which is the distance. This is unlike velocity, which is calculated from displacement. An example that distinguishes the two is that of an object traveling in a circle. This object can have a constant speed of, for instance, 10 meters per second, but its instantaneous velocity is changing since the direction of travel changes between any 2 points. The rate of change of velocity with respect to time is called acceleration, and it too is a vector quantity. This means that it has a specified magnitude and direction. When a car is increasing its speed, we call this acceleration, and when it's slowing down, we call it deceleration. Another good example of acceleration is that which happens when an object travels in a circular path. For instance, a car moving along a circular track at a constant speed has a changing direction of motion. According to our definition of a vector, this means that the velocity of the car is changing, but in terms of direction, not magnitude. This means that the car is accelerating, and this type of acceleration is called centripetal acceleration. More on that in a later video. So, with these quantities alone, we can describe the motion of any moving object far below the speed of light, of course. That will be our focus over the next few videos, so stay tuned. That's it for this one. Thank you for watching.